Alright, so week 24, part 2, first question. And by the way, these are all homework questions this week, so hopefully they look familiar to you. The first question says there's a log, and from that log we're going to cut a board out. So here are two possible scenarios, right? We've got this round log, and we could cut the board or the beam like that, or we could cut it like that. And so we're looking at the strength of the beam that's cut as a function of this angle theta. So what it says is that the strength of the beam is proportional to the width times the square of the depth, or the height. So the way we would express that mathematically is we could say this. We could say the strength is proportional to this little fishy. The alpha sign means proportional to the width times the square of the depth. And proportional to means, if this stuff doubles and this doubles, so the strength is related to. Next, so we could, so let's see, I'm trying to keep all that covered up, but if we were to SOHCAHTOA over here, we know that the log has a diameter of 20 centimeters, so the length of this, after doing SOHCAHTOA, is going to be 20 times the sine of theta, and the width of the board is going to be 20 times the cosine of theta. So we say that strength is proportional to the width, which is 20 cos theta, times the depth squared, so times this squared. So we can say that the strength is equal to, and there might be some constant in here. The back of the book answers have a little k, because proportional to just means sort of related to, not exactly equal to. 20 cos theta and then 20 sine theta squared. And after multiplying 20 times 20 times 20, we would get 8,000. We got the cos theta. And then look at how sine of theta squared, so this right here, we're going to be doing a bunch of this in the next unit. So sine of theta squared, this is just a shorthand version of writing it. We say sine squared theta. So that's what that means right there. Okay, so that's what the question was asking us to do, is write an expression for the strength of the beam in terms of theta, so as a function of theta. And there we go. Second question says, I'm going to use this to cover up our answers. So we are given that we have a 20-foot ladder and we're leaning it against the building, and the base of the ladder is 6 feet from the building. So we're supposed to find two things. What is the angle of elevation, and how high does the ladder reach? It says reach the top of the building. So first, angle of elevation, that means with respect to the ground, how much should we have to tilt it up? So that right there, this theta, this is the angle of elevation. So we have our little SOHCAHTOA over here. We're looking for our angle of elevation, and we're looking for the height. So I hope you're seeing that, hope you're seeing that if we say, I was zoomed in appropriately. If we say that if this is our angle here, theta, this is the adjacent side, this is the hypotenuse, so we can say that the cosine of the angle theta is 6/12, adjacent over hypotenuse, in which case the inverse cosine, or arc cosine, so I've been hearing people call this weird stuff, so this is the inverse cosine, or arc cosine, same thing, of 6/12 gives us the angle, and I typed it in, but I used the arc sine instead, and this looked weird, so I checked, and it gives us 72.5 degrees. In order to find h, we can say that tangent of the angle is the height over 6. So tangent of, and this says 72.5 equals h over 6, and so we get about 19 feet. I think it was 19.02. Okay, so these word problems, usually the math isn't that involved. The whole The challenge is reading the question and knowing what it's asking. So I always recommend students draw a diagram and label all the stuff. So I drew this and I labeled all this, drew this, made a little separate right triangle. I promise it's helpful if these are difficult for you. Alright, so next we have some like a flagpole, and here's the sun out here, and it casts some shadow. So this S stands for the shadow that the flagpole casts. Express the angle as a function of the length of the shadow. So what is this in terms of the length of the shadow? And then find the angle of elevation, this angle of elevation, when the shadow is 20 feet long. So, for the first part of our question, we could say, we know that this is the adjacent side and this is the opposite side. So we could say that the tangent of theta is the opposite over the adjacent, and what we're looking for is the angle as a function of the length of the shadow. So we need to get theta all by itself. We're going to do that by taking the inverse tangent of both sides. So we can say the inverse tangent of 50 over s equals theta. And this would be our equation that gives us the angle of elevation in terms of, so s is what we could plug in, and that is the length of the shadow. So we can use this formula to solve our second part of the question, find the angle of elevation, theta, when the shadow is 20 feet long. So, inverse tangent, oh I think I have this written right here, never mind. So if tangent of the angle is 50 over 20, then the inverse tangent of, and I reduced a little bit to get 5 over 2, and we should get something like 68.2 degrees. Alright. Next question. So we have a hot air balloon, and the hot air balloon is floating in the air, and it's tethered to the ground with some rope that's 680 feet long. And I think we're interested in how high it is. Let me try to not show you that answer. Ha ha ha. Okay, so here's our hot air balloon, 680 feet of rope, and you could be down here, not drawn to scale, and you could measure. We have a little angle measure thing. It's called a protractor, but we have another device as well. And so you can measure the angle where this is angle theta, and then from that you can figure out how high the balloon is. Okay, so first part, express the angle as a function of the height of the balloon. So it's going to be theta equals something where h is our variable. So hopefully you recognize that would be our opposite. This would be our hypotenuse. So we could say that the sine of the angle is the opposite over the hypotenuse, in which case theta would be the inverse sine or arcsine of h over 680. So that's what this is asking us to do. Express, meaning come up with the expression or equation, angle as a function of, so this would be the variable that we plug into to solve for theta. And down here, we're about to do that. Find the angle of the elevation if the balloon is 500 feet high. So if this is 500 feet, rope 600 feet, what is theta? So sine of our angle would be opposite over hypotenuse, and inverse sine of, and I reduced the 500 over 600 to a 5 over 6, and we got 56.4 degrees. Okay, so those were some good examples. And if you're actually listening, I'd like you to draw a little star on the bottom left of your corner. And bottom left corner of your paper. This is just for me to check to see who's actually watching these. Thanks.